Good morning, everyone. Let us study the interesting chapter, Whole Numbers, Class 6, Chapter 2. So, what are whole numbers? Whole numbers are the collection of all positive numbers which do not have any fraction or decimal. So, if we have a number line which has all the integers written on it, then the whole numbers starting from 0 and which lie on the right side of it are called whole numbers. So whole numbers are 0, 1, 2, 3 and so on. So what are natural numbers? So natural numbers are the numbers which we can count. Like 1, 2, 3, 4 and so on. We can count them on our fingers. And natural numbers along with 0 gives us whole numbers. So what is the difference between whole numbers and natural numbers? Natural numbers start with 1 while whole numbers start with 0. So what is a predecessor and a successor? Let us understand this with the help of an example. So there's a kingdom and there is a ruler. The child of the ruler would be next in line for the throne. So the child is the successor. The parent of the ruler would be the predecessor. Similarly, in natural numbers, the successor of a natural number is the natural number next to our given natural number, which comes after it. So if we add 1 to our given natural number, we get the successor. So for example, if we have 16, the successor would be 16 plus 1, which is 17. Therefore, 17 is the successor of 16. Similarly, for predecessor in natural numbers, it's a natural number which is just before a given natural number. So if we subtract 1 from a given natural number, we get the predecessor. So for example, for 16, if we subtract 1, that is 16 minus 1 gives us 15. Therefore, the predecessor of 16 is 15. So now let us solve some questions. So draw a number line for only whole numbers. Pause this video and try to solve this question. So in a number line with only whole numbers, we have 0, 1, 2, 3 and so on. Why? Because all whole numbers are positive numbers which do not have any fraction or decimal. So it includes all natural numbers along with 0. Next question. Write a whole number which does not have any predecessor. Pause this video and try to solve this question. So, whole numbers are 0 along with all natural numbers. So for 0, its predecessor should be 0 minus 1, which is minus 1, which is not a whole number. It's a negative integer. Therefore, a whole number which does not have any predecessor is 0. Now, write a natural number which does not have any predecessor. Pause this video and try to solve this question. So, natural numbers are all the numbers which we can count, like 1, 2, 3, 4 and so on. So, a natural number which does not have any predecessor. Let us try to solve this. So, let us find the predecessor of 1. So, the predecessor of 1 is 1 minus 1, which gives us 0. But 0 is not a natural number. It's a whole number. Therefore, the natural number which does not have any predecessor is 1. Now, write down the successor of 99,999. Pause this video and try to solve this question. So the successor of any natural number is the natural number plus 1. So adding 1 to 99,999, we get 1 lakh. Therefore, 1 lakh is a successor of 99,999. Now, this is an interesting question. Which one of the following is true? All whole numbers are natural numbers, or all natural numbers are whole numbers? Pause this video and try to think. which one of them is true. So, as we studied earlier, that whole numbers are the collection of all positive numbers that includes 0 as well as all natural numbers. So, all natural numbers along with 0 gives us whole numbers. Therefore, all natural numbers are whole numbers. Now let us try to understand a few properties of whole numbers. First, closure property. If we have a set with elements inside it which could be numbers, and if we apply an operation between two elements, and if the result of the operation gives us an element which belongs to the same set, then we can say that the set is closed under that operation. Let us try to understand this with the help of an example. So if we add two whole numbers like 1 plus 2, we get 3, which is also a whole number. Therefore, whole numbers are closed under addition. If we subtract two numbers like 5 minus 6, we get minus 1. But minus 1 is not a whole number. It's a negative integer. But if we subtract 4 minus 2, we get 2, which is a whole number. And hence, if we subtract any two whole numbers, we may not always get a whole number. Therefore, whole numbers are not closed under subtraction. Let us try to multiply two whole numbers. If we multiply two whole numbers, 5 multiplied by 6, we get 30, which is a whole number. Therefore, whole numbers are closed under multiplication. Let us try division. If we divide 5 divided by 10, we get 0.5. Which is not a whole number. Why? Because whole numbers are all positive numbers which do not have any fraction or decimal. But if we divide 4 divided by 2, we get 2, which is a whole number. Therefore, dividing any two whole numbers may not always give us a whole number. Therefore, whole numbers are not closed under division. Let us understand commutative property. In the commutative property, if we apply a binary operation for a pair of elements, then the two elements are said to commute under that operation. So let's try to understand this with the help of an example. If you have 5 chocolates and your friend gives you 6 more chocolates, then you have 11 chocolates. But if you have 6 chocolates and your friend gives you 5 chocolates, you get 11 chocolates. So therefore, 5 plus 6 is equals to 6 plus 5, which is 11. Therefore, whole numbers are commutative under addition. Let us try multiplication. So if we add 6 3 times, we get 6 times 3, which is 18. Now, if you try to add 3 6 times, we get 3 multiplied by 6, which is 18. So therefore, whole numbers are commutative under multiplication. So the order in which we multiply or add two numbers do not matter. Therefore, 5 plus 6 is equals to 6 plus 5, and 6 multiplied by 3 is equals to 3 multiplied by 6. Let us try to understand associative property. Associative property is a property of some binary operations, which means if we change the order of numbers inside the brackets, then the answer doesn't change. Let us try to understand this with the help of an example. We have 6 multiplied by 5, which is inside the brackets, and then multiplied by 4. So 6 multiplied by 5 gives us 30, and 30 multiplied by 4 gives us 120. Similarly, if we change the order, if we change the brackets, if 5 multiplied by 4 is inside the brackets and then we are multiplied by 6, therefore 5 multiplied by 4 is 20, and then 20 multiplied by 6 is 120. This is called associative property. The answer did not change by changing the position of brackets. Let us try to do this with addition. So 6 plus 5, it's inside the brackets and then plus 4. So 6 plus 5 is 11, and 11 plus 4 is 15. Now 6 plus 5, then inside brackets we have 5 plus 4. So 5 plus 4 is 9, and 9 plus 6 is 15. Therefore, the answer did not change when we change the order. Therefore, this is called associative property. Let us understand distributive property. In distributive property, it states that if we try to multiply a number with a sum of few numbers, then it is same as multiplying each of those numbers separately and then adding their products. Let's take a look at the example. So 5 multiplied by 9 plus 6. So 9 plus 6 is 15, and 15 times 5 is 75. Now, if we apply distributive property, we get 5 multiplied by 9 and 5 multiplied by 6. So 5 multiplied by 9 is 45, 5 multiplied by 6 is 30. So adding these two, we get 75. Let us study and complete this pattern. So we have been given a few operations. Try to solve this question. Now let's try another question. A taxi driver filled his car petrol tank with 40 liters of petrol on Monday. The next day, he filled the tank with 50 liters of petrol. If the petrol costs 44 rupees per liter, how much did he spend on petrol? This is a very interesting question and can be solved in multiple ways. Pause this video and try to solve this question. Let us find out how many liters of petrol did the taxi driver buy. So on Monday he bought 40 liters and on the next day he bought 50 liters. So total liters of petrol are 40 plus 50, which gives us 90. Since each liter of petrol costs rupees 44, therefore 90 liters of petrol will cost 44 times 90, which is 3960 rupees. Let us try to apply distributive property and solve it. So, on Monday, how much did the taxi driver spend on petrol? So, on Monday, he bought 40 liters of petrol. So, the cost of 40 liters of petrol is 40 multiplied by 44, which is 1760 rupees. Now, on the next day, he bought 50 liters of petrol. So, the cost of 50 liters of petrol is 50 multiplied by 44, which is 2200. So adding these two, 2200 plus 1760, we get 3960 rupees, which was the same as what we got earlier. Therefore, the taxi driver spent 3960 rupees on his car petrol tank. Now let us solve another question. A vendor supplies 32 liters of milk to a hotel in the morning and 68 liters of milk in the evening. If the milk costs rupees 15 per liter, how much money is due to the vendor per day? Pause this video and try to solve this with multiple ways. So let us try to find how many liters of milk did the vendor supply in one day. In the morning, he supplied 32 liters of milk. And in the evening he supplied 68 liters of milk. So in one day he supplied 32 plus 68, which is 100 liters of milk. Since the milk cost rupees 15 per liter, therefore the total cost of the milk is 15 multiplied by 100, which is 1500. Therefore 1500 rupees is due to the vendor per day. Now let us try to solve this using distributive property. Let us find out the cost of milk he supplied in the morning and in the evening separately. So he supplied 32 liters of milk in the morning. So the cost of 32 liters of milk will be 32 multiplied by 15, which is 480 rupees. And in the evening he supplied 68 liters of milk. That will be 68 multiplied by 15. So 1020 rupees. So adding both 1020 and 480 rupees, we get 1500 rupees. Therefore, 1500 rupees is the amount of money which is due to the vendor per day. I hope you enjoyed studying about whole numbers. If you would like to solve more questions and for further reading, you can always refer to your textbook. Thank you.